It's Edexcel GCSE Maths Higher Tier Calculator Paper 2 from June 2023. Let's get straight into it. Question number 1. Work out the value of this calculation. Write down all of the figures on your calculator display. All this is testing us on is, can we type this in correctly into our calculator? First thing that I'm typing in is this fraction button, which is over here. Then 25 minus the square root of 43.87 over 6 plus 2.1 squared. Squared button is over here. I'm just going to check that it's exactly the same as the one in the question. And yep, it is. And then I just copy out what my answer is, 1.7653. Your calculator might give a few more decimal places, so just write whatever you have. Part B, work out the value of the reciprocal of 0.625. Reciprocal just means that I need to flip this value. If I had this as a fraction, it would be 0.625 over 1 right now. I'm going to write it as 1 over 0.625. I've flipped it and type that into my calculator. So 1 divided by 0.625, which is 8/5. Question 2. Write 60 as a product of its prime factors. So we're going to use a prime factor tree for this one. I'm going to think of a number that 60 divides by. I know 6 goes into 60 and 6 multiplies by 10 would give me 60. What goes into 6? That would be 2 and 3, and both of these are prime numbers, so I would circle them. What goes into 10? That would be 2, and that would multiply by 5, and both of those are prime numbers. So to finish that off, I would write 60 is equal to 2 times by 2 times by 3 times by 5. That's equal to 2 squared times by 3 times by 5, and you can check this by multiplying all of these together, and you can check it also on your calculator. Typing in 60 and then press shift, and where these apostrophes are, you can see the word fact, and that would show you 2 squared times 3 times by 5, and that's the same as that. But you need to show the working out for that. Question 3. There are 48 counters in a bag. There are only red counters and blue counters. The number of red to the number of blue is 1 to 2. So let's write that. Red to blue is in the ratio 1 to 2. Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 8. Is Helen correct? So Helen's thought that to find the amount of reds, we have 1 out of 2, it's 1/2, so you just have to find 1/2 of 48. But Helen's incorrect because we need to find the total amount of parts first. 1 plus 2 is 3, so there's 3 total parts. So 48 is equal to 3 parts. How much would 1 part be worth? We need to divide by 3 on the right hand side and divide by 3 on the left hand side. 48 divided by 3 is 16, and we want the amount of reds, which is just going to be 16, and she thought it would be 24. Helen is incorrect, as there are 16 red counters. Question 4. N is greater than or equal to -2, so n could be -2 and above, and less than 5. And n is an integer. Integer just means a whole number, so like 1, 2, 3, 4, you're counting numbers. Let's write the numbers n could be. So we know it could be -2, -1, 0, 1, 2, 3, and 4. It can't be 5 because it's not less than or equal to. Write down the greatest possible value of n, so that would be 4. B, on the number line below, show the inequality m is greater than or equal to -4. So I'm going to draw a circle at -4 and I'm going to shade that in. Because it's a greater than or equal to, and there's more pen on the inequality sign, I put more pen on my circle. And it's less than 1, so I'm going to draw a circle at 1 also, and then I just need to connect those up. I don't need to fill this one in because it's not a less than or equal to. Part C, solve 2 over 5g minus 4 is less than 6. We're just going to treat this like an equation. What's happening to this g? It's being multiplied by 2/5, and then we're taking away 4. So we need to add 4 first to both sides. So now we've got 2/5 g is less than 6 add 4, which is 10. And g is multiplied by 2/5, so we're going to divide by 2/5 on both sides. So g is less than 10 divided by 2/5, which is 25. You can check this on your calculator. You could write this as an equation on your calculator by writing 2/5, and I'm going to write x instead of g, so I'm going to press alpha. Where this right bracket is, I can see there's an x here, so that will bring up x, minus 4, and then I want an equals, but I don't want to solve it yet, so I'm going to press alpha, and where this calculation button is, there's an equals here, and it's equal to 6. On your calculator, you might have to press equals twice. Mine, it does it straight away. X would be equal to 25, and you can see it matches up with this. Question 5. Here is a triangle and a rectangle. All measurements are in centimeters. The area of the triangle is 10 centimeters squared greater than the area of the rectangle. So this is saying if I worked out the area of the rectangle and I add 10 to it, it's the same as the area of that triangle. Work out the value of x. So how do we work out the areas of triangles? All we do is the base multiplied by the height divided by 2. So here the base is 8 multiplied by 6x, and that's been divided by 2. Easy way to do this, 8 divided by 2 is 4, so I'm going to do 4 times by 6x. 4 times 6 is 24, that's 24x. Let's do the same thing with this one. For the area of the rectangle, all we do is the base times by the height. So we're doing 5 multiplied by 4x minus 1. So we've got brackets, we're going to multiply everything outside the bracket by everything inside. 5 multiplied by 4x, 5 times 4 is 20, so that's 20x. 5 multiplied by negative 1 is negative 5. So the area of the rectangle is 20x minus 5, but if I add on 10 to that, it's equal to 24x. So let's create an equation with that. So 24x is equal to 20x minus 5, and then add 10. Simplifying this bit on the right hand side, 24x is equal to 20x minus 5 plus 10 would be plus 5. I need to move all my x's to one side, so I'm going to move them to the left hand side because it'll leave me with this 5 on the right hand side. Taking away 20x there and taking away 20x there. 24 take away 20 is 4, so 4x is equal to 5. X is being multiplied by 4, so I need to divide by 4 on both sides. So x is equal to 5 over 4, and you can leave it like that as a fraction. You can change it to a decimal, but it's not worth the effort. So the answer is just 5 over 4. Question 6. Last year, a family recycled 800 kilos of household waste. 57% of this waste was paper and glass. The weight of the paper recycled to the weight of the glass recycled was 12 to 7. Let's write that as a ratio. So P to G, the paper to the glass, was in the ratio 12 to 7. Calculate the weight of the glass the family recycled. So we're trying to find this value here. First, let's work out how much waste was recycled altogether. To work out a percentage quickly, all we need to do is take the original number and we're going to multiply it by the decimal of the percentage. So 57% as a decimal. To convert it to a decimal, we just divide by 100. That would be 0.57. So 800 multiplied by 0.57 would give us 456. So 456 kilos is being recycled. It's being recycled in this ratio 12 to 7, and we're trying to find out the weight of this glass, so 7 parts. So we're splitting up 456 into 12 and 7 parts, which is 19 parts, is equal to 456. What would 1 part be worth? We need to divide by 19 on the left-hand side, and we're going to divide by 19 on the right-hand side. So 456 divided by 19, which is 24. Let's multiply both of these by 24. We just need to multiply this one by 24. So 7 times by 24 would be 168. The glass that the family recycled was 168 kilos. Question 7. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. How do we write error intervals? We take the original number and we plus and minus the limit of accuracy divided by 2. Here the original number is 12.7. The limit of accuracy is just what has it been rounded to. Because it's 1 decimal place, it's rounded to the nearest tenth, or 0.1. So we're doing plus and minus 0.1 over 2. 0.1 over 2 is 0.05, so we're doing 12.7 plus and minus 0.05. Let's do the smaller one first. 12.7 take away 0.05 would be 12.65. And if we add 0.05, it gives us 12.75. The way you can check this, if you rounded this to 1 decimal place, it would become 12.7. And if you rounded anything smaller than this, that would also round to 12.7. Tamsin buys a house with a value of £150,000. The value of Tamsin's house increases by 4% each year. If it's a 4% increase, how would we write that as a decimal multiplier? If we're doing an increase, we do 1 plus the percentage as a decimal. So if it's a 4% increase, we do 1 plus 0.04, which means we'd multiply it by 1.04 to find the value of the house the next year. Rachel buys a house with a value of 160,000. The value of Rachel's house increases by 1.5% each year. Let's do the same thing with this one. We're doing 1 plus because it's an increase. 1.5% as a decimal is 0.015. So we're adding 0.015, which gives us 1.015. That's what we would be multiplying by if we want to find out the following year. At the end of 2 years, whose house has the greater value? Show how you get your answer. Because it's 2 years, we're going to use our compound interest formula, which is the original number multiplied by our decimal multiplier. We've already worked those out. To the power of the amount of repetitions. How many times is it happening? Let's do times first. So the value of the house was 150,000. The decimal multiplier is 1.04. It's increasing by 4% every year, and it's repeating twice because it's for 2 years. We'll type that into the calculator. So 150,000 multiplied by 1.04 to the power of 2, which is 162,240. Do the same thing with Rachel's. So that's 160,000 multiplied by 1.015 to the power of 2. $164,836. And I can see the tens of thousands and the hundreds of thousands are the same, but the thousands are different. Rachel has 4,000 and Tamsin has 2,000. So Rachel is greater than Tamsin, as 164,836 is greater than 162,240. Question 9. The cumulative frequency table gives information about the ages of 80 people working for a company. On the grid opposite, draw a cumulative frequency graph for this information. So I've got the table over here. Because it's a cumulative frequency graph, I need to plot it at the end point of the grouped frequency. So I'm going to plot it at 30 and 20 for my first one. So go along to 30 and up to 20, just put across. Then for the next one, I'm plotting at 40 and 48. So 40 and 48, which is here. Then for the next one, 50 and 64, 50 and 64. Next one is 60 and 75, so 60 and 75 is there. And the last one, 70 and 80. There's 2 ways you can finish this off. You can draw a smooth curve going through all of the points, or you can just do a straight line connecting each of the points. I'm just going to do a straight line because it's a little bit easier. Just 2 to go. And that's that graph done. Part B, use your graph to find an estimate for the median age. We know that there's 80 people altogether, and the median value will be the middle of these 80 people. So it's going to be 80 divided by 2, which is 40. We're looking for the 40th position. Let's look at our graph. I'm going to draw a line across from 40, and I'll draw a line going straight down. And it's between 30 and 40, and they're going up in ones. So that would be 35, that'd be 36, that'd be 37. So my median, my estimate for the median is 37 years old. Question 10. A biased dice is thrown 60 times. Bias just means the probabilities are not equal. It's not a fair dice. The table shows information about the number that the dice lands on each time. Gethin throws the dice twice. Work out an estimate for the probability that the dice will land on 6 both times. Let's first work out what the probability of getting a 6 is. If we get a 6 15 times out of 60, so probability of 6 is 15 out of 60, we can simplify that. 15 over 60 is the same as 1/4. So the probability of getting a 6 is 1/4. We're trying to find the probability that it will land on 6 both times. So that means we're finding the probability of multiple events. To do that, we need to multiply both events together. So we're getting a 6 and a 6 again. So we're doing 1/4 multiplied by 1/4. 1 times by 1 is 1, and 4 times by 4 is 16. Sally is going to throw the same dice n amount of times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? Sally is going to throw the dice a number of times. We don't know how many times she's going to throw it, but we just need to write a comment about the amount of times that she throws it. In the original question, she throws it 60 times, and it tells us she's using her results to work out a more reliable estimate. So that means she's going to have to throw it more than 60 times. Let's say she threw it 100 times, she's going to get probabilities that will be closer to the actual values. So the value of n will be greater than 60. And that way she'll get answers that are closer to her actual probability. Question 11. Use algebra to solve the simultaneous equations 2x plus 6y is equal to 5 and 3x minus 4y is equal to negative 12. The first thing that I'm looking for is one of the coefficients before either the x's or the y's to be the same. So this is a 2 and this is a 3, so that's not the same. And this is a 6 and that's a 4, so that's not the same. So I need to multiply both of these equations by something to get them to be the same thing. I'm going to try and get these x's to be the same because the lowest common multiple of 2 and 3 is 6, and I need to multiply them by smaller numbers than getting these y's to be the same. To get this 2x to become a 6, I'm going to multiply that whole equation by 3. And to get this 3x to become a 6, I'm going to multiply the whole equation by 2. Multiplying this first equation by 3, 2x times by 3 is 6x. 6y times by 3 is 18y is equal to 5 times by 3, which is 15. So I multiplied all of this by 3. For the second one, 3x times by 2 is 6x. Negative 4y times 2 is negative 8y. Negative 12 times 2 is negative 24. Now that I've got the same number before the x's, I can choose whether I need to add them together, these two equations, or do I subtract them. If I add them together, I'm going to get 12x, so I need to subtract them from each other. So I'm doing 6x take away 6x, which cancels each other out. 18 take away negative 8, so 18 add 8, which is 26y, is equal to 15 take away negative 24, 15 add 24, which is 39. Y is being multiplied by 26, so I need to divide by 26 on both sides. So y is equal to 39 over 26. Both of these divide by 13, so that would become 3 over 2, or 1.5. Now that I have the value of y, I'm going to substitute that into the easiest equation. I'm going to choose this first equation, and then I'll find the value of x. So 2x plus 6 lots of y, and I know y is 3 over 2. So 3 over 2 is equal to 5. I'm going to multiply this out to make it simpler. So 2x, 6 times by 3 over 2. 6 times by 3 is 18. 18 divided by 2 is 9. So 2x plus 9 is equal to 5. X is being multiplied by 2, then we're adding 9. So we're going to take away the 9 first from both sides. 2x is equal to 5 take away 9 is negative 4. Divide by 2 on both sides. And x would be equal to negative 2. So x is equal to negative 2. And y is equal to 3 over 2. And x is negative 2. You can check this by substituting both of these into these equations, and you would get an answer of 5 and negative 12. At this stage, you could also type it into your calculator with the method that I showed you before, and you would be able to solve it. But you do need to show you're working out, just in case you make any mistakes. Question 12. The points A, B, C, and D lie on a circle, center O. A, B, C, D is a rectangle, so this is saying that length is the same as that length, and that length is the same as that length. AB is 8, which is already on. BC is 10, which is already on. Work out the circumference of the circle. Give your answer correct to 3 significant figures. Circumference of the circle just means the perimeter around the edge of the circle, so we're trying to find what is the perimeter of this circle. How could we do that? What is the formula for circumference of a circle? It's cherry pie delicious, and the D stands for diameter, so we need to try and find the diameter. I'm going to draw my diameter from one corner of the rectangle to the other corner of the rectangle because I think I could find out that length. This base is also going to be 8 centimeters, and that height is 10 centimeters, and because it's a rectangle, that's going to be a right angle. That means I've got a right angle triangle, I've got 2 of my lengths, and I'm trying to find my longest length. So I'm going to be using Pythagoras. So that's a squared plus b squared is equal to c squared. With this one, I'm trying to find the longest side, so I'm going to square both of my sides, add them together, and then I'm going to square root that answer, and that will give me the length of that hypotenuse. 8 squared is 64, and 10 squared is 100, so I'm doing the square root of 164. I'm just going to keep it like that for now. It's better to use this than write it in decimals because I want to use my exact value. Now that I know my diameter, I know D, I can substitute it into this equation and I can find my circumference. So my circumference is equal to pi multiplied by root 164. Let's type that in. So root 164 multiplied by pi, which is 40.2320. We want to round it to 3 significant figures, so I'm going to count 1, 2, 3, draw my line there. This 3 is my decider, and it's telling me that I need to round down. It's going to stay the same, so it's going to round down to 40.2 centimeters, and that's to 3 significant figures. Question 13. ABC is a triangle. Calculate the size of angle BAC. So I'm trying to find BAC, which is this angle over here. Give your answer correct to one decimal place. The first thing that I can see here is I've got opposite pairs of information. I've got this side and I've got this angle, and I've got this side, but I don't have this angle. So that means I could use my sine rule. Because I'm trying to find this angle, I'm going to put my angles on the top. So sine of A over A is equal to sine of B over B. So sine of A, sine of 70 over the side opposite to it, which is 18, is equal to sine of B. This is the sine of B. We're trying to find that one. So sine X over the side opposite to it, which is 15. We just need to rearrange this. So on the right hand side, it's being divided by 15. So I'm going to multiply by 15. So 15 sine 70 over 18 is equal to, I've got sine of X left, and I want to move this sine over to the other side. So I've got the inverse sine on this side, and all of that will be in brackets, is equal to X. Just need to type all of this in, and I get my value for my angle. So the inverse sine, and then I need my fraction button, 15 sine 70 over 18, that's 51.543. So X is 51.5432. I want to find out this angle, so I need to use my angles in a triangle fact. All of these will add up to 180. So I just need to do 180, take away 70, take away my previous answer. That will give me the angle that I'm trying to find. So 180 minus 70 minus my previous answer, which is 58.4568. I want to round it to one decimal place, so I'm going to look after my decimal point. This 5 is my decider, and that's telling me that I need to round up to 58.5. It's an angle, so it's going to be in degrees, and that's to one decimal place. Question 14. Show that x squared minus x minus 6 over 2x squared minus 5x minus 3 can be written in the form ax plus b over cx plus d, where a, b, c, and d are integers. So I've got two quadratics here. I need to factorize both of them. I'll factorize this numerator first, so I'm looking for two numbers that multiply to make negative 6, this number on the end, and they add to make negative 1, the coefficient of this x. Let's write out the factors of 6 to help us. So factors of 6 are 1 and 6 and 2 and 3. But they're multiplying to make a negative, and they're adding to make a negative 1. So that means one of them will be a negative. So I think it's going to be this 2 and this 3, but we just need to decide which way around it'll be. Will it be positive 2 and negative 3, or negative 2 and positive 3? It's going to be negative 3 and positive 2. So I'm going to use that to factorize it. In the first bracket, it's going to be x minus 3. And in the second bracket, it's going to be x plus 2. That's my numerator factorized. Let's do the denominator. I can see this 2 is a prime number, so that means in the brackets, I'll have 2x and x. And this 3 is also a prime number, so I'm going to have 1 and 3. Let's just imagine we don't spot that. We'll just do it the normal way. So 2 multiplied by negative 3 would be negative 6. So we're looking for two numbers that multiply to make negative 6 and they add to make negative 5. We've already wrote out the factors of 6, so it's either going to be 1 and 6 or 2 and 3. I think it's going to be this 1 and this 6, but which way around will it be? They need to add to make negative 5, so it's going to be negative 6 and positive 1. So in the first bracket, because it's 2x squared, I'm going to write 2x minus 6, and for the second bracket, I write 2x plus 1. The last thing that I need to do is just look at both of these, and can I divide either of these by a common factor? In this one, I can divide both of these by 2. 2x divided by 2 would be x, and minus 6 divided by 2 would be minus 3. And this makes sense in terms of the question, because this is x minus 3 and this is x minus 3. This one I can't simplify any further, so that would be 2x plus 1. So now that I've simplified both of my quadratics, we're going to simplify the fraction fully. So on the top, I have x minus 3 and x plus 2. From my numerator, I've factorized it. And on my bottom, my denominator, I've got x minus 3 and 2x plus 1. That's that one. I can see I've got common factors, so I can cancel those out. And I'm just left with this x plus 2 on the top over 2x plus 1. Question 15. Here are the first four terms of a quadratic sequence: 3, 9, 17, and 27. Find an expression in terms of n for the nth term of the sequence. The first thing that I'm going to do is look for my second difference. So what is it going up each time first? It's going up by 6, and then by 8, and then by 10. My second difference is the difference between these. So here, it's always going up in 2s. And because this number is 2, whatever number this is, I just divide it by 2. So 2 divided by 2 is 1. And this is telling me the number before my n squared. So it's just going to be 1n squared or my square numbers. Let's write out my square numbers. So I've got 1, 4, 9, and 16. And now I'm looking for the difference between n squared and my original sequence. So from there to there, I've added 2. From here to here, 4 to 9, I've added 5. From 9 to 17, I've added 8. From 16 to 27, I've added 11. So now I need to look for the nth term of this sequence. This one is going up in 3s, so I'm going to write 3n first and write my 3 times table. So 3, 6, 9, 12. And I'm looking for the difference between my 3 times table and this sequence in red. So from there to there, I've taken away 1. From there to there, I've taken away 1. From there to there, I've taken away 1. So now I can combine all of these three things. So I've got n squared, 3n, and this minus 1. I just combine all of them, and I can write n squared plus 3n minus 1. I can check this. Let's say I want to check this 27. Because this is the fourth term, 1, 2, 3, 4, I would substitute 4 into here, and I would get 27. Question 16. The histogram gives information about the number of hours some students used their phones last week. The histogram is incomplete. One thing that we need to remember when we're using histograms is that the area of the bar, the area of the rectangles, will tell us our frequency. The formula triangle that we're using is the frequency is equal to the frequency density multiplied by the class width. It says 28 students use their phones between 30 and 40 hours. So this area over here between 30 and 40 is going to equal 28. So we know that the difference between 30 and 40, the size of the class interval is 10, and we're multiplying that by something to give us 28. So that would be 2.8. So the height of this bar will be 2.8. So if I put 2.8 there, that would mean that each of these would be worth 1. That'd be 1, that'd be 2, that'd be 3, and that'd be 4. 24 students use their phones for between 40 and 60 hours. Use this information to complete the histogram. So we know that there's 24 students, so the area of this section here between 40 and 60 will be 24. The class interval is between 40 and 60, so the class width is 60 take away 40, which is 20. So this is my class width, and that's my frequency. To work out my frequency density, I'm going to do frequency divided by my class width. So I'm doing 24 divided by 20, which is 1.2. Just look for 1, it's going up in 0.1s, so I'm just going to draw my line from there, cross to 60, and then down to 60, and that's that one done. Part B, no student used their phone for more than 60 hours. So that's saying that there's nothing on the right hand side of this. Work out the total number of students. All I need to do here is work out the areas of all of these. I'll just write 24 here because it told us that in the previous part of the question. In this area, we've got a length of 20. That's going to be multiplied. That's 1.5, so that'd be 1.6. 1.6 times by 20 would be 32. Then we've got between 20 and 30, so the distance is 10. We're multiplying that by, that'd be 3.5, that'd be 3.6. So that area would be 36. All we need to do now is just add up all of these frequencies. So we're doing 32, add 36, add 28, add 24. And that would give you 120. So there's 120 students altogether. Question 17. Show that the equation x to the 4 minus x squared minus 5 equals 0 can be written in the form x equals the 4th root of x squared plus 5. The clue here is this 4th root. That's telling me that I need to get rid of this power of 4. And you can see there's no power of 4 here. So the first thing I'm going to do is I'll move everything over to the other side apart from this x to the 4. So I'm going to move all of this to the right hand side. So now I've got x to the 4 is equal to, moving this to the other side, it's going to become x squared plus 5. And then to get rid of this power of 4, we just need to take the 4th root of both sides. So it's going to be the 4th root of x squared plus 5. And you can see this one matches up with this one. Part B, starting with x0 is equal to 1.5. That's going to be my first value. Use the iteration formula, the 4th root of x squared plus 5, 3 times to find an estimate for a solution of x to the 4 minus x squared minus 5 equals 0. The key word here is iteration. That means I'm going to be repeating this 3 times. So I'm going to find x1, x2, and x3. For the first value, we're going to substitute 1.5 into here and see what we get. And then we'll substitute that value into the next one. So we're swapping this x with 1.5 squared plus 5. Just typing this in. Looking for this button over here where you can see the square root and it's got a square below it and a square above it. That means you can type in the 4th root and whatever you're trying to find the 4th root of. So I'm pressing shift and this button and it should show up like this. I'm going to press 4 there, so that's giving me the 4th root. Press right, and I'm typing in 1.5 squared plus 5. That gives me 1.6409. For the next one, I'm going to substitute this value into the same thing. I'm swapping this 1.5 with this 1.6409. Easy way to do it, you could just go backwards, and you could swap this with an AND button, and then it'll just give you the answer. So it's 1.6654. For the next one, again, swapping this with my answer button. That gives me 1.6698. The way you can check this is if I substitute this value, 1.6698, into here, I would get something very, very close to 0. So what you're doing here is you're approximating the solution. You're getting closer and closer to the actual answer. Question 18. 2a to 5c is equal to 6 to 25. So I'm just going to write that 2a to 5c is equal to 6 to 25. I can find what a and c is if I divide this side by 2 to get a on its own. So I'll have a, 6 divided by 2 would be 3. And I'm going to do the same thing with this right hand side. Because this is 5 lots of c, I'm going to divide both of these by 5. So c will be 25 divided by 5, which is 5. So I know a to c is 3 to 5. Then I've got this next ratio. I'm going to do the same thing. 4b to 7c is equal to 20 to 21. So I'm going to divide both of these on the left hand side by 4. 20 divided by 4 gives me 5. Same thing with this c, dividing both by 7. That gives me c. 21 divided by 7 is 3. So now I've got ac and bc. I'm going to write them all together so I can see them a little bit more clearly. I've got a to b to c, and I'm going to write 3 to 5 under my a and my c. And I'm going to write 5 to 3 under b and c. And whenever you're doing these, you're looking for one column where you have 2 pieces of information. So I can see c has 2 pieces of information. So it's almost like we're trying to get equivalent fractions. What's the lowest common multiple of 5 and 3? It'd be 15. So what do I multiply this 5 by to get to 15? I need to multiply it by 3. And what do I multiply this 3 by to get to 15? I need to multiply it by 5. 5 times by 3 would be 15, and 3 times 5 would be 15. So I do 5 times by 5, which is 25, and 3 times by 3, which is 9. So now I can see the ratio of a to b to c. Show that a plus b to b plus c is equal to 17 to 20. So we've already found a to b to c. We just need to do a plus b, which is 9 and 25, to b plus c. b plus c is 25 add 15. Just simplify both of these. 9 and 25 is 34. 25 add 15 is 40. You can divide both of these by 2 because it's even. 34 divided by 2 is 17, and 40 divided by 2 is 20. And you can see we've got the same ratio that they wanted there. Question 19. ABC is a right angled triangle. AB is 9.3 centimeters, correct the nearest millimeter. So you can see it's already there. Let's just write what the error interval for this one would be. So the error interval is the original number plus and minus the limit of accuracy divided by 2. Here, the original number is 9.3. Because it's to the nearest millimeter, let's just think, how could we write millimeters in centimeters? So I know 1 centimeter is equal to 10 millimeters, but I just want 1 millimeter because I'm rounding it to the nearest millimeter. So if I divide this by 10, I get 1 millimeter. That would be 0.1 centimeters. So I'm rounding it to the nearest 0.1 centimeter. So I'm going to do plus and minus 0.1 divided by 2. So that's 9.3 plus and minus 0.05, which is equal to, I'll do the smaller one first, 9.25 is my lower bound, and my upper bound, 9.3 add 0.05 is 9.35. AC is 12.6 centimeters, correct to the nearest millimeter. So I'm going to do the same thing with this one. 12.6 plus and minus 0.05 is equal to, that'd be 12.55 lower bound, 12.65 for the upper bound. Calculate the lower bound for the size of the angle marked X. I'm trying to find the smallest possible angle this could be. Show all your working. We know we're going to be using trig here. Let's first label our sides. We've got the side opposite the right angle, which is the hypotenuse. The side opposite the angle, which is the opposite. So I only need these two. So which ones from SOHCAHTOA are we going to be using? We're looking for O and H, so that's going to be sine. It's going to be sine, the inverse sine, because we're trying to find an angle of the opposite over the hypotenuse. So it's O over H. And let's just have a think about this. we're trying to get the smallest possible angle, so we're going to have to try and get this as small as possible. And if you're not sure whether you're trying to maximize this or make this as small as possible, you could just try two different values and substitute in and see which gives you the smaller one. Does the big one give you the smaller angle, or does the smaller one give you the smaller angle? So I'm trying to minimize this value, O divided by H. So for my numerator, I want a really small number, and I want to divide it by something as large as possible. So I'm going to choose my lower bound for my opposite, which is AB. I'm going to choose my upper bound for my hypotenuse, which is AC. So the inverse sine of the lower bound of my opposite, which is 9.25, that's that one. And I'm going to use my upper bound for my hypotenuse. So that's 12.65. Just type that in. So the inverse sine of 9.25 over 12.65. And that gives me 46.9892. I'll just round this to one decimal place. So I'm looking after the 9. That 8 is telling me that I need to round up. So that's going to go to a 0, and I need to carry 1 into my unit. So it's going to become 47.0, and that be in degrees to one decimal place. Question 20. ORT is a triangle. O to T is equal to A, and that's already on. R to T is equal to B, and that's already on. M is the point on OR, so it's over there, such that O to M to R is 2 to 3. This is saying this line is split up in a ratio 2 to 3. So altogether, there's 5 parts. So that means this part of the line will be 2/5 of the line, and this part of the line would be 3/5 of the line. Express MT in terms of A and B. So I'm trying to find this vector over here, M to T. Give your answer in its simplest form. So the first thing that I can see, I don't have this vector from M to O, so I need to find that vector. But I can't go from M to O yet. I need to find the vector of RO, and I'd rather find the vector of RO because I'm going to go from M to T, and I'm not going around the other way. So let's find RO first. RO, I'm going down to T, so I'm doing add B, and then I'm taking away A. That gets me from there to there. So this vector over here is B minus A. And I just want 2/5 of that to get from M to O. So now we're going from M to T. I just want 2/5 of B minus A. And then I'm adding one more lots of A. I'll expand this bracket out. So I've got 2/5 multiplied by B. So 2/5 of B minus 2/5 of A plus A. And because all of these are in fifths, 1 whole is the same as 5/5. So I'm going to write it as 5/5 A, and it'll just make it easier to add up later. So I've got nothing that collects up with this B, so I'll just rewrite that as 2/5 B. Then I've got minus 2 plus 5, which would be plus 3 over 5A. That's my final answer. I can't simplify that. Question 21. Here is a graph of y equals f of x. On the grid below, draw the graph of y equals f of x minus 4. So I've just copied the graph of y equals f of x. When it's minus 4 on the outside, that means that it's shifting down by 4 places. So I need to move all of these coordinates down by 4. Let's start with this one because it's easiest. That's 1, 2, 3, 4. So that point would appear there. This point would just be here. This point would be there, and that one there. And I just need to connect them all up. I would do this with a pencil just in case you make any mistakes, but I'm just doing it with blue so that you can see it a little bit more clearly. That's that one done. Part B, on the grid below, draw the graph of y equals f of minus x. And the minus is before the x, it's inside the bracket. For this one, it's going to be a reflection in the y-axis. And the y-axis is the one that's going up and down, the vertical one. So I need to flip it over here. It's going to reflect in this line. So this point is going to stay exactly in the same place. This is 1 unit away from the y-axis, so it's going to appear here. That will be over here. And this one is 3 away from the y-axis, so it'd be there. And then I'll just draw that on. Question 22. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. So I'm going to write blue to red is in the ratio 4 to 1 because the blues are 4 lots as many as the reds. Rita takes at random 1 pen from the box. She records the colour of the pen and then replaces it in the box. This is quite important. Because she's replacing it, the probabilities won't be changing. They're going to stay the same every time. Rita does this n amount of times where n is greater than or equal to 2. So she's going to repeat this more than 2 times. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. What does it mean to get a blue pen at least once? let's just imagine we only have 2 picks. We know we're going to have 2 or more, but we'll just imagine we have 2 picks. To get a blue pen at least once, you could have blue and red, you could have red and blue, or you could have blue and blue. But instead of working out all of these, you could just find red and do 1 minus that. And the same would apply to the red pen at least once. You could just do 1 minus blue. That's if it was 2 picks, but we don't know how many picks there are altogether. So we're going to have to use n for the amount of times that it's going to happen. We're doing 1 minus the probability of getting red an amount of times minus the probability of getting a blue an amount of times. Let's just work out the probability of getting red and blue. So red would be equal to, there's 1 out of 5 altogether. And for blue, it would be 4 out of 5 altogether. So we're doing 1 minus, for the probability of red, it's 1 over 5. And because we don't know how many times it's happening, we're going to raise it to the power of n. So this just means it's 1 over 5 times 1 over 5 times 1 over 5 times 1 over 5 repeatedly, but we don't know how many times it is. And I'm going to do the same thing with the blues. So it's minus 4 over 5 to the power of n. So it's the same as that one. And I can't simplify that, so I would just leave it like that. Question 23. Here are 3 similar triangles, ABG, ACF, and ADE. So similar just means that they're enlargements of each other. The angles will be the same, but the lengths will be multiplied by a scale factor. ABCD and AGFE are straight lines, so that's a straight line and that's a straight line. AB to BC to CD is equal to 1 to 2 to 3. So A to B is 1 and A to C is 2, so this distance is 2. I'm going to draw these as separate triangles just so that I can see a little bit more clearly. So I've got my first triangle, which is the small one, AGB, and that length is 1. Then for the next one, I've got AFC. I'm told that BC is 2, so B to C is 2, but I know AB is 1, so 1 and 2 would be 3, so that length would be 3. Then I've got ADE. I know CD, so this length is 3, that length was 2, so the full length of that triangle, the large one, is 1 plus 2 plus 3, which is 6. Now that I've got all my lengths, I could use that to help me with the rest of the question. Show that the area of ABG is this triangle, to the area of BCFG is this trapezium, to the area of CDEF, this trapezium, is 1 to 8 to 27. Let's first work out the areas of these triangles. We know what the ratio of the length scale factor is. It's 1 to 3 to 6. So the area scale factor, because I know what the length scale factors are, that would be x and that would be x squared. So I just need to square all of these. 1 squared is 1, 3 squared is 9, and 6 squared is 36. So the area of this is 1, the area of this triangle is 9, and the area of this triangle is 36. We already have the area of ABG, which is 1. We need to find the area of BCFG. So BCFG is this trapezium over here, and I need to find the area of this large triangle, and I take away the area of this small triangle over here, ABG. So I'm doing 9 take away 1. So that's 9 take away 1 for that one. For CDEF, I'm finding the area of this trapezium. So I need to find the area of the large triangle, and I need to take away the area of the middle-sized triangle. So the large triangle is 36, and the medium-sized triangle is 9, so 36 minus 9. So ABG is just 1. Then BCFG is 9 take away 1, which is 8, and it matches up with that. And then CDEF is 36 minus 9, which is 27. And you can see our answer matches up with their answer. Question 24. The diagram shows 8 identical regular octagons joined to enclose a shaded shape. Each octagon has sides of length A. I'm just going to label a few of these. So that's A, that's A, that's A, and that's A. Find, in terms of A, an expression for the area of the shaded shape. Give your answer in the form P 2 plus root 2 A squared, where P is an integer. Show all your working. Because I've got a regular octagon, I'm just going to first find out what shapes that I'm working with here. What angles do I have? How would I find each interior angle? I could find out the total of all of the angles by doing 180 multiplied by n minus 2. That's my total interior angle formula. Because I want to find each interior angle, I'm going to divide it by my number of sides. And here I have 8 sides. It's an octagon, so I'm doing 180 multiplied by 6. 8 take away 2 is 6, divided by 8. 180 multiplied by 6, and if I divide that by 8, I get 135. So this angle is 135, that'd be 135, that'd be 135, that'd be 135, and that'd be 135. They're all going to be 135. I'm just going to concentrate on these ones around here. I can see I've got angles around a point, so that means all of these will add up to make 360. So I'm finding this missing angle over here, taking away 135 times by 2, because that's 2 lots of them, 360 take away 270, which is equal to 90. So that angle would be 90, and that angle would be 90. That's telling me two things. I've got two types of shapes going on here. I've got right angle triangles, and I need to find the area of 4 lots of them, and I've got this large square. It's a square because all of the sides are equal, and all of the corners are right angles. So I'm going to first find out the area of these triangles first. Let's do the area of the triangles, and I need to remember I need to multiply it by 4 because I've got 4 lots of them. How do we work out an area of a triangle? We just do base times by height and divide it by 2. I know the base is A and the height is also A, so I'm doing A times by A, divide it by 2, and because there's 4 triangles, I'm multiplying it by 4. A times A is A squared, and divide by 2 times by 4 would simplify to times them by 2, so I've got 2A squared for all of my triangles. That's the triangles done. I now need to work out the area of a square. So how do I do the area of a square? I need to multiply my base by the height. But I can see I've got part of the base. I've got this A and I've got this A, but I'm missing this part over here. I need to find that length. How could I do that? If I just concentrate on this bit over here, I've got a right angle triangle. I've got 2 of the sides and I'm missing one of the sides. I'll just draw that over here. I've got A, and I'm trying to find this length here, the hypotenuse. So I'm going to be using Pythagoras. That's A squared plus B squared is equal to C squared. Quick way of doing this, because I'm finding the longer side, the hypotenuse, I'm going to square both of these. So that's A squared, and I'm going to add them together, so A squared, and I'll square root that answer. A squared plus A squared, that's 2 lots of A squared, so that's root 2A squared. Can simplify this a little bit, so I'm going to do the root of 2, and the root of A squared is just A. So this is the same as root 2A. Now that I know this length is root 2A, I can find out what that whole base is. It's going to be A plus A, which is 2A, plus root 2A. I can see I've got a common factor of A. I'm going to pull A out just to make it easier to expand later. A multiplied by 2 would give me 2A, and A multiplied by root 2 would give me root 2A. Now that I've got my side length, I need to square this. So I get my area. So A brackets 2 plus root 2, and all of this is being squared. So I'm going to put another bracket around that, and I'm going to square it. This is saying that A is being squared, and all of this, the 2 plus root 2, is also being squared. 2 plus root 2 squared. I'm just going to do this separately. So I've got 2 plus root 2, and it's being multiplied by itself. So I'm multiplying by 2 plus root 2. 2 times 2 is 4. 2 times root 2 is 2 root 2. Root 2 times 2, again, 2 root 2. And root 2 times root 2 is 2. 4 add 2 is 6. And 2 root 2 plus 2 root 2 is 4 root 2. I've expanded this bit out, so I'll rewrite it below. A squared, and this is being multiplied by 6 plus 4 root 2. And you can see I'm getting something close to this. I'm going to expand out this bracket because I feel like it'll be easier if I expand it out and then I factorize it later on. So 6 times by A squared is 6A squared, and 4 root 2 times by A squared is 4 root 2A squared. So this is the area of my square, and this is the area of all of my triangles. I just need to combine all of them. So my total area is 2A squared plus 6A squared plus 4 root 2A squared. I can combine these two, so I've got 8A squared plus 4 root 2A squared. And remember, I want my answer to look something like this. So I need 2 plus root 2 inside the bracket. I'm going to factorize this. I can see I've got 4 as a common factor of the numbers, and I've got A squared as a common factor of both of these terms. So I'm pulling out 4A squared. What multiplies by 4A squared to give me 8A squared? That'd be 2. To get this 4 root 2A squared, I just need to multiply it by root 2. And you can see I'm getting very, very close to this. The only thing that they've done differently is they've wrote this A squared on the right hand side. So I'll just rewrite it as 4 brackets 2 plus root 2. And on the other side is A squared. And these two match up with each other. And it matches up with the answer that I've got here. That's the end of the questions today. I recommend you have a look at all of them and write down topics that you struggle with before you send them to the past paper. Feel free to contact me or reach out if you need any help with anything. Otherwise, you can check out my channel for more walkthroughs and lecture tutorials on GCSE, including ones from GCSE, LCC.